Greetings everyone and welcome back. So up till this point we have seen the general architecture of Puppet and went through the installation and configuration of Puppet Master and Agent. In this section we will learn firstly the basic concepts of Puppet resource declarations and how it uses resource abstraction to specify the desired state of Puppet nodes. Then we will start with Puppet programming by first defining the nodes. Then we will go ahead and learn what are user manifests. After that, we will in individual videos look into what are file manifests, service manifest, and package manifest. In this video, we will be firstly talking about the resource abstraction layer and then the imperative style of programming used in Puppet. So first, we will look into how the resource abstraction layer contributes to Puppet's ability to take a description of a resource and implement it using providers. The resource abstraction layer is important to understand how Puppet works with different operating systems as well as with different Linux distributions. A resource can be considered as all the resources which are used to model any configuration in Puppet. They are basically inbuilt resources which are by default present in Puppet. They can be considered as a set of resources belonging to a predefined resource type. They are similar to object-oriented programming concept in any other programming language, wherein the object is an instance of class. In Puppet, its resource is an instance of a resource type. So Puppet's secret sauce is abstraction. Abstraction can be considered as a key feature where the resources are defined independently from the target operating system. In other words, while writing any manifest file, the user does not need to worry about the target machine or the operating system, which is present on that particular machine. In abstraction, resources give enough information about what needs to exist on the Puppet agent. The resource abstraction layer allows the user to define characteristics of a resource regardless of the implementation in a consistent way. Every resource follows the same syntax, which is a resource type, for example, a user, package, service, or file resource type, curly braces to define the resource block, a title separated from the body of the resource with a colon, and a body consisting of attributes and value pairs. When configuring a node, Puppet Agent uses a document called a catalog, which it downloads from a Puppet master server. The catalog describes the desired state for each resource that should be managed, and can specify dependency information for resources that should be managed in a certain order. Puppet compiles a catalog using three main sources of configuration information. The first is agent-provided data, the second is external data, and the third is Puppet manifests. All of these resources are used by both agent or master deployments and by standalone Puppet apply nodes. So let's review the Puppet catalog compilation process. In step 1, the Puppet master retrieves the node object. Once the Puppet master has the agent-provided information for this request, it asks its configured node terminus for a node object. By default, Puppet Master uses the plain node terminus, which just returns a blank node object. This results in only manifest and agent-provided information being used in the compilation. In step 2, Puppet loads factor and provides information about itself via facts. This information can include a multiple of variables such as the operating system, CPU architecture, block devices, and network information. Based on that information, the Puppet Master creates a catalog for each individual node. This catalog describes the work for a specific node and contains the desired state for each resource and the dependencies. In step 3, Puppet now parses the main manifest file. The node's environment can specify a main manifest to use. If it doesn't, the Puppet Master will use the main manifest from its configuration file. The main manifest file can contain any arbitrary Puppet code. Finally, in step 4, after Puppet has evaluated the main manifest file and any classes it declared, it will load from modules and evaluate any classes that were specified by the node object. resources from those classes will be added to the catalog. If a matching node definition was found in step 3, these classes are evaluated at node scope, which means they can access any node scope variable set by the main manifest. If no definitions were present in the main manifest, they can be evaluated at top scope. So this is it for this video. In this video, we went over the resource abstraction layer and Puppet catalogs. We also went through how the catalogs are compiled and then applied to set the desired state of each node.